Okay, the velocity of the planets is actually kind of misleading here with my animation that I showed you, because what I'm doing here is I'm actually using the celestial sphere as a reference frame. So I'm actually freezing it. Normally it would be spinning counterclockwise, and so we have all these planets here spinning in a reverse rotation. You see they're all moving clockwise except when they're in retrograde, and that's because I used the celestial sphere as a frame of reference. Normally the celestial sphere is the fastest object in the sky, rotating at 23 hours 56 minutes and 4 seconds sidereal time. So what you have to picture or understand is that the planets that are moving, like if the sun is at the top here and they're moving further away from the sun toward the right, it looks like they're going faster. It's actually the reverse. They're going slower. And so out of all the planets, ironically, the slowest planet is Mercury. You would think Mercury is the fastest planet. Well, except while in retrograde, where the sun actually magnetically whips it back in front of him. Same thing with Venus. But normally at cruising velocity, like the cruising velocity of the ecliptic way, think of it like a highway, like when the cars are getting off the ramp and going back on the ramp, slowing down and speeding back up, affected magnetically by the sun, you're going to have a set speed for these planets to move at their cruising velocity rate. So out of all the planets, the one that has the most movement in this animation is going to be the slowest, which is Mercury. Except again, why I said when it's whipped back into retrograde. And then Venus would be the second slowest. I see, here's the sun, here's Venus. Venus is going to the right. That means it's slowing down. It's not faster, it's not speeding up. When it gets to a point where it's gotten really slow, it starts to move, I guess because of the magnetic flux of the sidereal flux, or the front of the sun, it's getting pulled. So the sun actually pulls it magnetically, and it causes it to increase in velocity slightly like that. So out of all these planets, Neptune would be the fastest planet, even though it looks like it's the most motionless here in this diagram, because it's in sync with the celestial sphere. Remember, real true rotation is counterclockwise. Okay, so this false rotation is just to give you a reference frame and understand the paths of the retrograde. But normally we're not going to see these, this is just one frame, is one set time of each day. But normally they're moving counterclockwise. And so that's all the planets are doing. They're slowing down and speeding back up, being affected by the sun. This diagram will actually help you, this animation here, where we have the sun and we see the planets. So whatever's going to the left of the sun, it means that the sun is faster. So we see Mercury, it's going to the left. Normally it goes to the left, but then it gets whipped back in front of the sun. That's the only time that it's faster than the sun, when it goes into retrograde. Same thing with Venus. Venus is over here. Normally, for the most part, it's slower than the sun, but then it gets whipped back in front of the sun, but then it slows back down to its normal cruising velocity, which is slower than the sun. Now you see the other planets, they are constantly going faster than the sun. Like you can watch Neptune or Jupiter. Jupiter's going faster, see? Faster than the sun. Saturn, faster than the sun. All these interior planets, I call them interior, heliocentrists would call them exterior, are moving faster than the sun because they're more in sync with the celestial sphere. So the planet in which you think is the slowest, Neptune, or if Pluto exists, because it's more in sync with the rotation velocity of the celestial sphere, it's actually the fastest. And so Mercury is actually the slowest. And now the moon, I think the moon is going to be
Okay, this is actually an addition to this video that I uploaded about a year and a half ago. I talked about the moon wrongly. I said that the moon was going to be slightly faster than Mercury and Venus, but no, the moon is slower. The moon is slower. It's going at 24 hours and about 50 minutes per day. And as you see the moon going from the right to the left really fast, that indicates it's slowest out of all the celestial objects that I'm showing here. So, and also too, when you see this stellarium version of the celestial sphere in stereographic mode like that, when Venus and Mercury move to the right like that, that's when they're going faster. They actually are going in front of the sun, even though it appears that it looks like they're going behind the sun during that time. So just for clarification, that's what you guys need to understand.